This vector question is a really neat logic problem. Essentially, once you know where the different points are on the cuboid, it's going to be quite easy to find AE, but we are not told where they are. We're simply told that A, B, C, D, and E are five of the vertices. Okay, we are given that AE is a diagonal, and that means like the long diagonal, but we're not told anything else. So let's have a go at finding out, basically like labeling the cuboid, and then we can find the position vector of OE. Right, I'm going to draw a cuboid. And maybe I stick the origin down here. Don't forget we have that. Now I can label one of the, I'm just going to put some dotted lines down. I can label one of the points A, and it doesn't really matter where that is. So this is, sometimes we say without loss of generality, label A bottom left. I don't think you necessarily have to write that. But when you go on to, making stronger mathematical arguments at some point, then it's important just to say I haven't missed any specific cases. And the result would be that this has to be E. This follows on from that because we're told that AE is a diagonal. Now, what I'm going to do is I'm going to find the different vectors. So if I want to find AB, I don't know where AB is, but let's just imagine I've got A here, O here, and B here. Then to get AB, it would be minus A plus B, or equivalently B minus A. It's always the second one minus the first one. I was just trying to explain why and remind you about that, but we can write that down because then we can start finding um, these vectors. So I don't think you need to show all your work in here, -1, but just be careful because it's very easy to make a mistake, -7. So that gives me the vector AB, and like it's a good idea, I think, is to find the lengths as well, because if we can show that some lengths are the same, that can help us identify potentially where they are. So AB, we can just use 3D Pythagoras, so it would be 1 plus 25 plus 49, which is going to be root 75. I also do this because in part B it starts asking about the volume of a tetrahedron, and we're going to need lengths for that. And we can keep going. Now, I'm not going to keep referring back to this, like you've seen this. I have done this question on paper, so I'm just going to start writing down what I've written now. And then we can do AD. Sometimes you can just sort of spot it. It's going to be root 125. So those are all the ones that we can link to point A. Next is going to be what we can link with B. Well, we've already dealt with BA essentially. We don't need to do that again. So we just need BC and BD. Note that we haven't got a single one the same, because that could potentially help because you could maybe figure out that two of them are the height or something like that. And then finally, the only one I've not looked at is CD. Okay, and if you didn't know how to start this question, then, remember, you can always sort of just pause it at this point and think, okay, I got the lengths. Right, now what can I do with them? If you're not sure, then watch on. Well, as you can see, all five lengths are different. And you think, how many lengths are there actually on this cuboid? And if we start labeling them, like we can see that, because remember, all of these could, like this is not necessarily a square. I didn't mean to make it into a square. So this would be like length one, just along here. And then maybe we say that length two is the same but in the going into the page, and length three is then going up. So we've dealt with all of those. What else is there? Um, well, we could also have diagonally this way. That could be length four, and diagonally this way. That's length five. And that's all the possible different lengths. I mean, okay, there is AE as well, but we know we don't have that one. So, okay, there's six lengths in total. I'm not going to draw that one in. Or maybe I will. Actually, in fact, I will because I'm going to draw it like that's kind of what we're trying to get to at the end of it. If I want OE, then I can use OA and then get from A to E by using some of the other vectors. So I'll leave that one in. So there's six possible lengths. We've got with five that don't involve E. We've got those five. And remember those lengths, like if I consider a point over here, that it would be the same. Like there is only five lengths from here. So what I'm trying to say is these five different lengths are going to be somehow, these or equivalent somewhere on the cuboid. But that doesn't really help us. We don't know where they are. Um, although there is one that we can use. So I'm going to put that one in now. I'm pretty sure I'm correct in this, but I'm going to look at the largest length, and that is AD. Now, there's no way that AD, because I've got three, remember, 3 points from A to B, A to C, A to D. Um, now, there's no way that they could all be these just like the height or the base or going into the page. It's got to be that D is going to be across a diagonal from A. Not E, but a different diagonal. And so what I can do is I can just put point D, say here, and I can then say like it's without loss of generality. I could equivalently have like put it over here, but like you can just imagine rotating the cuboid a little bit, and then it would end up, in the same sort of place anyway. So that doesn't matter. I'm pretty sure I'm correct in saying that. So I can put D there. Um, so root 25 is the longest length. Now that still actually doesn't help me work out B and C. So we need to resort to some other aspects of vectors. And remember, this is a cuboid, so these lines are perpendicular. They're at 90 degrees. So if we can work out with some of the vectors, the dot product essentially, and try and get it equal to 0, then we can see which ones are equal to 90. Um, and this just kind of, you just got to maybe have like you can either calculate. I mean, there's a lot to calculate, or you can just kind of have a quick glance at some of them and see if it works. So if you look at BC and BD, we're going to get minus 16, then I'm going to get plus 10 and plus 6. So that is going to equal 0. That one's going to work. So BC dotted with BD is equal to minus 16 plus 10 plus 6 equals 0. So BC is perpendicular to BD. All right, and let's keep going. Let's try and find some more. If you now look at AB and CD, then we're going to get 8 plus 15 Um, no, sorry, that one doesn't work, does it? Okay, so I can see that they're not perpendicular. Actually, AB and BC. So I get -4 plus 10, or is it -10? Yeah, -4 -10 plus 14. That one also works. So AB dotted with BC is equal to -4 -10 plus 14 equals 0. And then a third one is AB and BD. I get 4 minus 25 plus 21. That will equal 0 as well. So this will allow us to label the rest of the cuboid. Just going to put these up here to help. Um, right, we need to think about this carefully. Now we've got, it's good to look at one that involves A and D because I've been able to label D because of the diagonal. So AB is perpendicular to BD. So the only place that it can be for that to make sense is here. So I've dealt with that one. Now I've got that AB is perpendicular to BC, and that must mean that C is up here. And then BC is perpendicular. Okay, I've not even needed to use that one, but that one also checks out. So um, we're sorted. And it might have been, I wonder if yeah, no, I needed to put D somewhere. I don't think I could have done this without having put D along one of the diagonals. What I have now then is the ability to find out OE, because OE is going to equal OA. That's going to get me onto the cuboid. And then I can see that I can go along. I can go from A to B to get to here. There's different ways you can do it. Oops. So I've gone to A and then I've gone to B. Now I can go up BC. So I'm here and then I want to go from C to E, but that will be equivalent to B to D. So I can just add on BD. I'm just going to borrow that, bring it down to the bottom. So this is the trickiest part. It's like a little logic problem to try and figure it out. Once we've done that, we're okay. So we're going to get 1, 2, minus 1 from above, plus -1, -5, -7 from above, plus 4, 2, -2 from above here, and then -4, 5, and -3. Add these together, you can see that they're going to cancel. The 5 and the -5 are going to cancel. I'll be left with 4 over here. I'll get -8, -5, -13. Oh, we found it. Good job. Finally, we're asked to find the volume of the tetrahedron ABCD. So I've got A, to B, and then it's going to be, the base is going to be here. I'm going to shade that in fact. And then it's going to go up to this point here. And so what I can do, I don't know why I'm in area here, the volume is going to be 1/3 times the area of the base times the height. Now the area of the base, well, this is a right angled triangle, so it's going to be 1/2 times AB times BD, and I just times by the height, which is BC. And at this point, actually, if you didn't see it already, this is actually going to be 1/6 of the total area of the cuboid. So it's 1/6, and then we can use these from earlier. We're going to get root 75, and then we've got BD and BC. So root 50 and root 24. Of course, we'll be expected to simplify these surds. So I'm just going to simplify each third individually. 25 goes into this one, so it's going to be 5 root 3. 25 goes into this one, it's going to be 5 root 2. And this one, what goes into it? I think 4 is the biggest square number. So it's going to be 4 times 6, so it's going to be 2 root 6. Now, we're going to get a 6 by doing root 3 times root 2 times root 6. That will give us 6, and that will cancel with the 1/6. So it's just 5 times 5 times 2, 50 units cubed.